Hi everyone, here is question 70 on stoichiometry. This one is really interesting. It's very interesting. So 25 ml of ethanoic acid solution. Ethanoic acid is a weak acid. It requires 40 ml of 0.500 molar sodium hydroxide, that's a strong base, for complete titration. What is the molarity of ethanoic acid solution? So let us write a very nice equation for this reaction first. Ethanoic acid, that's CH3 COOH, reacts with sodium. Oh, that's not sodium, that's potassium, right? It's potassium hydroxide. What will be formed? So we're going to have this H here going out, and then you see this K to come into that position there. So that means we have CH3COOK, and then we have H2O. Right, so it's still an acid and base. You still have salt and water. And then from the look of things, it's balanced. We don't need to put any coefficients anywhere, do we? No, 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 no. All right, so everything is good. Okay, 25 ml of ethanoic acid, that's 25 ml here. It requires 40 ml of this guy, 40 ml of a 0.5 molar. Great, so what's the molarity of this one? What's the concentration of this one? We don't know. Right, so let's look at the number of moles we can get from the KOH, because we have two things there, so we'll use it. 0.5 multiplied by 40, that's concentration multiplied by volume. Remember, concentration equals number of moles over volume, so that means the number of moles would be concentration multiplied by volume, okay? Just make sure your units are consistent. So 0.5, that's the molar, also known as mole per liter. So I need to have my volume in liters, right? So I have to do 40 divided by 1,000 to convert milliliters to liters. So yeah, what would that give us? So that gives us 0.02 mole rather. That's the number of moles of KOH. Now, pay attention. The number of moles of KOH has to be equal to the number of moles of ethanoic acid for this reaction to happen. Okay? For the reaction to be complete, the number of moles of KOH must be equal to the number of moles of ethanoic acid. Does that make sense? Good. So it means that the number of moles of KOH would be the same as the number of moles of ethanoic acid. That just means that by implication, number of moles of ethanoic acid must have also been 0.02. Otherwise, this reaction will not have taken place and they will not have given us this question at all. Okay? So that's it. Number of moles is that. Now that we know the number of moles of ethanoic acid is that, remember that concentration or molarity is supposed to be equal to number of moles divided by volume. Now I want to use the same equation to tackle the ethanoic acid. Number of moles is 0.02. Volume is 25 ml. Therefore, I can get my molarity. Are you ready? 0.02 divided by 25, right? I need to always divide this guy by 1,000 for unit consistency. So can you solve that in your calculator and let's see what you get? So I'm getting 0.8 molar. That's what I'm getting. You see, at this point here, whenever some students are faced with this kind of calculation, you have already done everything right. It's just to impute this in the calculator and get your answer. Sometimes that particular point might lead to some problems, but I think it might be helpful if you work on this first, write your answer down, and then do 0.02 divided by 0.025, and then you get your 0.8, okay, just to be on the safe side. or you just use some brackets at the denominator area so that calculator solves that first. Anyway, that's your answer. This is question 70. And if you're learning chemistry, keep doing it, keep practicing, and also keep teaching people around you, right? Your friends, because the more you teach people, the more you know it for yourself as well. That's a wonderful trick. A lot of people don't know that. A lot of people don't believe that. But anyway, it's true. So that's 70. If you're watching this on YouTube, subscribe, okay? And hit the like button as well if you found this helpful. 71 to 100 is still coming your way. And after stoichiometry, what other topics should we tackle? Let me know in the comments. And I guess I'll see you guys on 71. Bye bye.